Welcome to This Explainer. Today, we're taking the source material and embarking on an absolutely epic, chronological journey to witness the ultimate, natural demise of our planet. When we think of global threats, our minds usually jump straight to dramatic, sudden events, like a massive asteroid strike out of nowhere. But the truth mapped out in the data is actually far more methodical. So, we are going to trace the exact timeline of Earth's slow, inevitable transformation. So what will Earth actually look like in 1 billion years? Let's dive right into this massive question by projecting way past our modern era. We're going to see how our life-giving sun, the very star that sustains us, eventually orchestrates Earth's end. We're assuming a purely natural progression here just to see exactly how geology and cosmic evolution will entirely reshape our home. To really anchor ourselves, just think about the sheer scale of time we're dealing with. 1 billion years ago, Earth was basically an alien world. There were no plants, barely any oxygen, and just a single clustered landmass. Well, 1 billion years from now, our future planet is going to be equally foreign and unrecognizable, totally reshaped by a brightening sun. Let's quickly trace our roadmap for this timeline. At 100 million years, new mountains rise. By 250 million years, a new supercontinent called Pangaea Proxima forms. Hitting 500 million years, the sun brightens noticeably. And finally, at 1 billion plus years, we enter a runaway greenhouse effect. Okay, let's break these down. Our first major milestone is 100 million years out. Now, Earth's surface is incredibly malleable. Thanks to plate tectonics constantly shifting things around, our planet is getting ready for a truly dramatic geological facelift. What's really staggering about this era is the sheer scale of the change projected by the data. Africa is going to completely collide with Europe and Arabia. That means the Mediterranean Sea, it's entirely erased, gone. In its place, a massive new Mediterranean mountain range will rise up, and it could actually dwarf Mount Everest. Meanwhile, Australia is going to just plow right into Southeast Asia. Fast forward a bit to 250 million years, and all those moving landmasses crash together to form a brand new supercontinent known as Pangaea Proxima. This is a huge deal because it closes off the Atlantic and Indian Oceans, which completely disrupts the global conveyor belt of ocean currents. Without that vital circulation, the deep sea essentially loses its oxygen, and that triggers a massive marine extinction. And honestly, the conditions waiting inland on this new supercontinent are horrific. Because Pangaea Proxima is so incredibly vast, the inner continent transforms into this harsh, barren desert where temperatures reach a blistering 55 degrees Celsius. To put that in perspective, the only habitable zones left for land mammals will be pushed all the way out to the extreme poles. Now, before things heat up even more, we have to talk about Earth's built-in thermostat. It's called the carbonate-silicate cycle, and it's a delicate four-step process that naturally regulates our climate. Step 1, volcanoes emit CO2. Step 2, that forms acid rain, which weathers rocks. Step 3, those minerals wash into the ocean where marine life uses them to build shells. And step 4, when they die, that carbon gets subducted right back into the mantle. It's a perfect regulating loop. But at the 500 million year mark, that perfect loop permanently breaks. The sun, which is kind of acting like a terrible gift giver, delivering a planet-ending amount of heat, becomes 5% brighter. This extra energy hyper-accelerates that weathering process we just talked about. It starts sucking carbon dioxide out of the atmosphere way faster than volcanoes can possibly replace it. As those CO2 levels plummet, it triggers what is literally a plant apocalypse. See, C3 plants, which make up about 95% of today's biomass, including practically all our trees and crops, need high CO2. They suffocate and die off first. This leaves only a tiny fraction of highly resilient C4 plants, which can survive on just 10 parts per million of CO2 to fight a brilliant but ultimately losing battle. Which brings us to the crucial milestone exactly 1 billion years from now. The sun becomes 10% brighter. And this extra solar radiation, this is what truly begins dismantling the fundamental systems of our world. The cascading effects here are just catastrophic. Global surface temperatures skyrocket to 50 degrees Celsius. The oceans begin to evaporate faster than rain can ever replace them, creating a runaway greenhouse effect. With the plants gone, oxygen practically vanishes, dropping to 1% of modern levels. And crucially, because there's no surface water left to lubricate the Earth's crust, our tectonic plates permanently freeze in place. We actually only need to look next door at Venus to see exactly what this looks like. trapped at a crushing 460 degrees Celsius under a thick, toxic atmosphere. Venus is the exact dry, suffocating fate awaiting Earth. With our tectonic plates completely halted, volcanoes will just slowly burn trapped carbon dioxide into the drying air, wrapping our entire planet in a stifling blanket. Let's push even further, 2.8 billion years into the deep future. The sun is now 28% brighter. Surface temperatures hit a staggering 190 degrees Celsius. At this point, the very last remnants of life, these hardy, salt-loving microbes tucked away deep in underground ice caves, they finally perish. Earth becomes completely, entirely sterile. Roughly 6 billion years ahead, the core cosmic engine of our solar system starts to fail. Our sun finally exhausts its hydrogen stores. Without the outward pressure of nuclear fusion, its core collapses under its own immense gravity, and the star begins swelling into a monstrous red giant. At its absolute peak, about 7.6 billion years from now, the sun will expand to an unbelievable 256 times its current size. It will shed immense amounts of mass, and its outer boundary will stretch out so far that it entirely engulfs Earth's current orbit. Now, for a while, scientists debated if Earth might sort of safely drift outward as the sun lost mass. But recent satellite data paints a pretty grim picture. Lead author Dr. Edward Bryant noted that while they expected to see this effect, they were still totally surprised by just how efficient these dying stars seem to be at engulfing their close planets. Our world will be completely consumed, leaving absolutely nothing behind but a cooling white dwarf over trillions of years. So, with our planet vaporized and completely erased from the cosmos billions of years from now, we arrive at the ultimate question for us today. Does humanity simply accept this grisly, unstoppable fate? The source material points out something absolutely crucial. Humans have a compulsive habit of rewriting nature's story. If we survive long enough, we could theoretically deploy a grand escape plan. This could involve massive planetary engineering to intervene in natural cycles, maybe terraforming specific regions of Earth to buy us a few more million years. Or, the ultimate solution, colonizing other planets and star systems long before our sun goes rogue. Ultimately, though, it's really important to remember where we came from. The heavy elements in our bodies, the iron in our blood, the calcium in our bones, they were all forged in ancient stars. So, even if our home planet is entirely consumed, it is beautifully, poetically fitting that its elements, and perhaps ours, are finally reunited with the stars. As we wrap up this explainer, I want to leave you with this final thought. Knowing the immense, seemingly unstoppable natural forces waiting in the deep future, just imagine the incredible innovations we might build. I mean, if we can map out the exact demise of our planet billions of years in advance today, what will we be capable of inventing to outlive the very star that gave us life? Thanks for joining me on this explainer, and keep looking up.